In this video, we're gonna solve a problem where we want to find the surface area of solid obtained by revolving the function f of x, the graph of the function f of x equals square root of 3x plus 1 between 0 and 5. And we can actually make a sketch of the graph to just see how the solid looks like. So between 0, if x is 0, f of x is 1. If x is 5, f of x is 4. So 0, 1, and 1, 2, 3, 4, 5, 4. So 0, 1, and 5, 4. So it's a curve. And we can actually put here, what about 2? For 2, it's square root of 7, which is 2 point something, right? So the graph would be something like this. Now, if we rotate it over, let's say, about x-axis, because if we think about it, the formula that I wrote here is when the function is rotated about x-axis, the solid is gonna look like this. And if we want to find the surface area, we are going to use the formula. So S equals integral, and we also know the limits of integration, so it's between 0 and 5, 2 pi f of x square root of 3x plus 1, I didn't need the parentheses actually, and then times square root of 1 plus f prime, so I do need to calculate f prime for my problem, so I'm going to calculate f prime of x here. So just let's remember that square root of x prime, it's 1 over 2 square root of x. You want to memorize this because it's a pretty common formula. So in our case, it's going to be 1 over 2 square root of 3x plus 1, but let's not forget it's times 3x plus 1 prime, which is times 3, so we get 3 over 2 square root of 3x plus 1. So I used chain rule. So when we replace back into the formula, we wrote the formula up to this step. So now I have f prime, which is 3 over 2 square root of 3x plus 1, everything squared dx. So let's do the math. 2 pi, it's a constant, it comes in front, integral from 0 to 5, square root of 3x plus 1, times square root of, and I'm going to square this quantity here, so it's going to be 9 over 4 times 3x plus 1 dx. So integral from 0 to 5, square root of 3x plus 1 times, and because this is 1 here, and I can put it 1 over 1, and I want to add two fractions, I need the same denominator, so it's going to be 4 times 3x plus 1 plus 9 over 4 times 3x plus 1 dx. So right at this point, we are not doing any calculus, we are just doing algebra to simplify the integral. So at the numerator, and I also have a deep radical, so my decision is to separate into two radicals, a radical at the top and one at the bottom. So at the top is going to be 4 times 3x, 12x, and then 4 times 1 is 4, plus 9 is plus 13. And then the denominator, it's 4 times 3x plus 1, but because it's a multiplication between the two, I'm going to move the 4 outside the radical, so it's a 2 at the denominator. And then dx. Now, all the math that we did, it's supporting canceling these two with these two from here, so we get pi integral from 0 to 5 of square root of 12x plus 13 dx, which can be done using substitution. So u equals 12x plus 13, du equals 12 dx. So our integral now, it's integral pi integral of square root of u times, since du is 12 dx, then dx it's du over 12. So this 12 can be moved outside du. So we have pi over 12, u to 1/2 plus 1, that's 3 over 2, times 2 over 3. If we can simplify, and we get pi over 18 u square root of u, but the original problem was in x, so I'm going to replace it back and use the same limits of integration. So 12x plus 13 square root of 12x plus 13 from 0 to 5. So we get pi over 18, and then when we replace x with 5, we get 73 square root of 73, and then minus, and now we replace x with 0, and we get 13 square root of 13, and we'll leave it like this. And this is the work for our problem.